Well, let's say we have a little afternoon project. We want to go out in the backyard and string up a sloper antenna. And we'd kind of like to know what bands I might be able to cut that sloper for. And as it turns out, we have a convenient tree out there that I can string a wire up in. And let's make it look a little bit like a tree. So here's our tree. You can tell what a gifted artist I am. Alright, so there's our tree. And we need to know the height of this tree. We'll just call that X, and that's to the ground level, of course. And the tree is more or less perpendicular to the ground, which is important. We're doing this in late afternoon, so we're getting some nice shadow off this tree. So there's its shadow on the ground. And we have a tape measure and a yardstick and our trusty scientific calculator. So we go out here and stick a stake in the ground about where the top of that shadow is and measure the distance from the base of the tree. And we'll say that that's about 43.5 feet. And we're going to be dealing with triangles. We're going to use some trigonometry relationships, but they're pretty straightforward, so don't freak out if you've not had trig. You can still do these calculations. We're going to use the idea of similar triangles, and that says that, well, let's get our yardstick in the ground, because we need two triangles to do this. So this is our yardstick. We know that it's 3 feet tall. It also casts a shadow on the ground. And so we measure this, and we find that this is 2.3 feet. And we know that these are similar triangles because they have this angle. This angle is going to be the same in both of these. So that's what makes this work. And let's just call this A, B, and C for the sides. Same thing over here. This is A prime. This is B prime. And this is C prime. And the relationship is that A to A prime is the same relationship or ratio as B is to B prime, the same as C to C prime. So this is the idea of similar triangles. We have two sides of this triangle plus one of the sides of this triangle, and it's unknown, and we can use this setup to find out the height of the tree. So 43.5 is to 2.3. What our unknown side X is to 3 feet. And this is a proportion. When you have one ratio equal to another ratio, that's a proportion. But that doesn't matter. The mathematical mechanics here is that we can cross multiply. This is an equation, but it's just simpler to solve if we put it out more horizontally here. So 2.3 times our x value is equal to 3 times our 43.5. That's calculator time. That's more than I can count on my fingers. So 3 times 43.5 gives us a value of 130.5. And then to isolate x, we'll divide both sides by 2.3. That cancels to 1. So x is approximately equal to our answer over here of 130.5 divided by 2.3. And we see then that 56.7 feet, let's just round that up to 57 feet. That's the approximate height of the tree. Alright, so now that we know this, and let's write this in, 57, that's a 7, it would be very handy to know what this hypotenuse is, because in doing this sloper, you know, the idea is we've got our feed line coming up the base of this tree, and maybe we have some kind of a transformer here, impedance transformer, or balun or unun, whatever it is, and then we have our antenna wire going up the tree, and it's going to come down and fasten on the ground. This is the idea of our sloper. We need to know this, the hypotenuse here. So we're going to use the Pythagorean theorem that says, and that works for any right triangle, a square plus b square is equal to c square, where a, b, and c are the sides. Well, we know what a is. That is 43.5. We're going to square it, plus the height of our tree, which is 57. So we'll put our 57 in there and square that. And that's going to give us a value that represents side c squared. So let's do that in the calculator over here. So 43.5 squared plus 57 squared gives us a value. I'll do it down here. Our c squared value then is about 41.25, and if we take the square root of both sides, that cancels that out, so we get c then is equal to the square root of whatever this stuff is. So let's do the square root of our answer up there, and we see then that the length of that side is about 71.7. Let's just round that up to approximately 72 feet. So now we know the lengths of what we're dealing with here, and we can figure out the length of our element here depending on what band we're cutting that element for. At least we have the dimensions now that we know what we're dealing with, and that was the whole point of this exercise. And you can do this clearly without doing any math at all. You could just throw your wire up over there and stretch it out wherever it is, and without doing any math. But this will help you understand, or so much understand, but be able to figure out what bands you can cut for, given that these are the dimensions that you're working with. And this idea of similar triangles and the Pythagorean theorem, these come into play all over the place in helping you string up antennas, because many of them turn out to be triangles, and you can use these basic trig principles on how to do that. I think I'm going to do another video where I'm going to show you a relatively simple way of finding out what this angle is, because we can save some calculations in determining the length of these sides if we can get this angle. And we just need to add one other little common item you can buy in any drugstore or Walmart. So tune in to the next video to figure out how to deal with that. All right, have fun.